Welcome back once again to how to build an RTS in Unity. Today, we're going to be tightening up the movement of our units and looking at various ways we could achieve a more seamless arrival at their destination. One of the viewers of the last video commented that the units are kind of bumbling around looking for their destination when moving in packs. So today, we're going to take a look at fixing that. Let's start by discussing some of the options we have in tackling the problem. The main reason this is happening is because the first unit is arriving at the destination and is then blocking it for the others who share that same destination. The problem gets bigger and bigger the more units you have, so let's see how we can address it. The first option would be to simply map out a grid of destination points for each of the units like this. If we go this way, it'll definitely look better for the most part, but we'll have one small problem, which is that it isn't always guaranteed that each of these blocks will be free on the terrain, and that something like a building or a rock isn't obstructing their destination. The obvious solution to this would be to do a raycast for each position and make sure that there's nothing blocking it. Then, if there is, we can assign a new destination for that unit. This can of course get quite expensive if we're sending, let's say, 200 units to a destination, because then we'll need to do 200 raycasts at once. This isn't terrible, but let's look at some other options. Another way of solving the problem is to monitor the magnitude of each unit while moving, and if we notice that they're slowing down, we'll do a raycast in front of them and see if there's a unit ahead which shares the same destination and is stopped. If this is true, then we can stop our unit too. This feels like a better solution to me, but it can get a little tricky to get it right, because raycasts only look straight ahead of you. This could be a problem when trying to get past a unit which is just a little to the side, because the raycast won't see them. Another way we could try would be to do an overlap sphere cast anytime we slow down and check whether there's another unit nearby who shares the same destination and is stopped. For me, this feels like the best solution so far. However, overlap sphere calls can get pretty costly when you have a lot of units making them. So the solution I'm going to go with is one which is really simple. Might seem a little clunky, but does the job really well and is pretty performant. Since Unity handles massive amounts of colliders really well, we're going to attach an extra collider to our unit and put a trigger on it which will do the job for us. Let's start by opening the SWAT guy prefab, and let's create a new game object as a child called moving range. Now, let's go to the Project tab and open up our scripts folder. From here, let's right-click and create a new mono behavior script, and let's call this moving range. Now, let's attach it to our moving range game object by selecting moving range, going to inspector, and dragging and dropping moving range onto the object. Then we can go back into our scene view, open up another inspector on the right, and click on add component, and let's use a capsule collider. We can define the bounds of the capsule collider by clicking on the Edit Collider button, and we can just drag the edges. From the top view, we'll see that this collider is just a little bit bigger than the inner collider. So let's make sure that we select the moving range collider again, and let's check is trigger, and only allow it to interact with the unit layer. Now, let's open up our unit script. And let's go to the top of the script, and we can add a new serialized field. And let's make this a type of moving range. We can also call it moving range. Then we can hit save, and let's go back to Unity. Now, with the unit selected, we can drag the moving range object and drop it into the slot. And let's save and close this prefab. With that done, we can open up the moving range script. And let's bring up the onTrigger enter and onTrigger exit methods. At the top, we can also define a private list, and we'll make that a list of type unit, and we'll simply call that units in moving range. Let's also bring up the start method, and let's initialize our list. Now, on the onTriggerEnter method, we'll do a try_get_component on the other collider. So we'll say if other.try_get_component, and out of this we want to try get the other unit. If it is in fact another unit, then we want to make sure that the list doesn't already contain this unit. So we'll say if units in moving range dot contains other unit, and let's change this to a not with an exclamation mark. And if it doesn't contain that unit, then we're going to add it to the list. So units in moving range dot add other unit. Then let's do the same for onTriggerExit. First we'll check if other.try_get_component out unit other unit, and then we'll say if units in moving range dot contains the other unit. Then we want to remove that unit. So we'll say units in moving range dot remove other unit. The last thing we want to do for this script is to add a public method called getUnitsInRange. This is just going to return the list of units in range so we can access them from other scripts. So right below the start method, we can make this public and return a list of unit and call this getUnitsInMovingRange. And we're simply going to return units in moving range. You might be wondering why we're always creating public methods for retrieving the values of private variables instead of just making them public. Well, the reason I do it this way is to follow the concept of encapsulation. What we're doing is to prevent the outside scripts from changing private values and potentially breaking them. This gives us more control over our codebase and a degree of peace of mind knowing that no other script is going to randomly assign an incorrect value or clear the current value of one of our variables. Encapsulation is a fundamental concept in programming, which is considered good practice to follow when working on any codebase. So while it might feel like more work overall, it's a really good habit to form and will make your life much easier in the long run. Okay, let's get back to the code. Now that we have a way of retrieving the list of units within moving range, let's head back to the unit script and go to the update method where we're currently doing our distance to destination check. Currently, we're checking to see whether the navmesh agent's remaining distance is lower than the stopping distance, and if it is, we're stopping moving. Over here, let's add an else statement, and let's run a quick loop through all of our units in moving range. So we'll type for each unit in moving range dot get units in moving range. All we need to do now is to check whether our current destination matches the destination of the unit in range and whether they're stopped. To do that, let's create one more vector3 function which returns the current destination of the navmesh agent. So we'll type public vector3 get current destination, and we'll simply return the navmesh agent dot destination. Now we can go over here and say if unit in moving range dot get destination is equal to our navmesh agent dot destination, and the unit in moving range is no longer moving. Then we can stop moving and we can hit save. Let's hit save and let's head back to Unity. We can open our game tab and let's hit start. Now we'll take these units and move them to a destination, and you'll see they stop relatively well. We can make two more changes to make this look a little cleaner. Firstly, back in our unit script, let's adjust the stopping distance to be something a little lower. Let's go with something like 4. We can hit save and let's hit start. Let's try it now. And it's starting to look a little better. The units are definitely stopping in the correct position, however the animation is still running. So the last thing we'll want to adjust is to stop the game, go to the project tab, animations, and we can open up the SWAT guy controller. And let's take the arrow going back from SWAT guy run to SWAT guy idle, open the inspector, uncheck has exit time, and let's adjust this value over here to 0.15. And let's do the same for SWAT guy firing, so that the same thing happens when he reaches his target. Now we can go back to our game, hit start, and that looks much better. Great. Much better. There's still quite a few things we need to implement to make the movement better, but I think this is more than enough for now, since we have quite a lot of other mechanics to implement in the upcoming episodes. In the next episode, we're going to bring in another unit and show how splash damage can be used to hurt multiple units with one shot. Until then, thanks for watching, don't forget to wishlist Fungal Front on Steam, and have a great day.